So I'll move on to the next one. Got 3 more that I chose. Oh, this is interesting. I don't know if you guys have seen this before, but I don't think I've seen it. So yeah, super short problem, right? So I'm going to relabel the stuff in the end. So we have an inscribed quadrilateral with center O. And we'll just relabel A, B, C, D. Oops. May hide some stuff. Yeah, I think I might have to click on things and say to hide it. Oops. So we draw the 4 orthocenters of those triangles. We want to show that they're collinear. It's kind of interesting. I've never seen this before, but have any of you seen this?
I didn't see it too.
All right. So whoops. So AOB and BOC. Then, so yeah, we really only need to prove it for 3 of them, right? So those are the 4 orthocenters of.
Can you also draw the 4th one?
Okay. There we go. Delete. Whoops. Close this. So yeah, might as well draw these 4. So GO is so well I guess so we know we have a couple things we know. GO and E are collinear, OH and I are yeah, so it's probably useful. But that's obvious. Sorry, it's just. So maybe it's worth like drawing the circumcircle of BOC and letting GE hit it at a point, and then G would be like the reflection of that point over BC. Let's see. CG and AF are parallel. There are lots of parallel lines. So CG and AF are parallel, similar BJ and BH would be parallel.
Can you name the intersection of diagonals?
Yeah.
Probably these 5 points are collinear.
Okay. Yeah, it looks like they are.
So maybe we can take the two orthocenters, which are symmetric to O, and the point M.
If we prove that AGCF is a parallelogram, we are done. Is that true? AGCF? Well, that would mean that wouldn't that mean that DJBH is a parallelogram? But that doesn't look true, right? But I don't know if, are you sure AGCF is a parallelogram?
G and F are not symmetric actually.
They're symmetric? I'm sorry.
No, they're not symmetric, so they're not parallelogram, I think.
Yeah. So yeah, I only need to draw two of the centers. So do you want me to draw BOC and
G and J. G and J are enough.
G and J? Okay. So H and F,
Actually, they are not enough, but
oh, because we could know that G, J, and M are collinear, but then the others could be collinear with M, but that doesn't mean all four are collinear. So yeah, it's not enough, I guess.
And also check that if these 5 points are collinear, because I'm not sure if M is on the line.
Okay. Yeah, we kind of, let's see. Let me move it around. Yeah, I think it's true.
Okay, yeah.
But yeah, let me just make sure. But yeah, I think AG and CF intersect. Oops. Oh, no.
Can you make the diagram bigger?
Yeah. Sorry. So. One sec, guys. I'll be right back. All right, thanks for waiting. I wonder if it's worth reflecting O over each of the sides, because then we get a bunch of cyclic quadrilaterals. So whoops.
Maybe we can find another special point on this line other than M.
It's possible. So for example, if I reflect O over each of the sides, then M lies on KE and LI. Is that true? Really?
It's a lemma, well-known lemma.
I'd heard of Newton's theorem, but I don't think that's
Can you delete the other circle?
Yeah.
Michael. If you call X and Y is the midpoint of BD and AC. So yeah, and just no, don't need to rename. You don't need to rename. Just call and AC too. Yeah. So NOP will be collinear.
Yeah, that's Newton's theorem, right?
Yeah, and I think that OPN is perpendicular to GI the line the line we need to prove. So the point is so we can we write another problem that given triangle ABC and a circle and a circle that tangent to be BA to BA and BC, right? So call X and Y is the orthocenter center of OAB and OAC.
Okay.
Yeah, prove that line and call P is midpoint of AC. So proof OP is perpendicular to that line, and I think that will prove prove the problem.
Oh, really?
Maybe.
Like it was another video I did?
So G is enough, I think. We don't need other points, just G. Because if we prove that GM is perpendicular to an OP, then we are done.
So yeah, we really just need G, right?
Are they really perpendicular? Can you check it?
Yeah, I should check that. Let me just make sure. Yes. Okay.
Can you also hide li and
Hide what?
li and ke?
Okay. Yeah, I feel like there's not enough problems about like inscribed or tangential quadrilaterals. Okay, so is M the orthocenter of GNP? I don't think so. Hmm. I like this idea showing that GM is perpendicular to NP. But so NP, it's I guess another way to say, I don't know if this makes things any easier, but we could draw the circle with center N passing through D, B and D, and then we could draw this circle. And we want to show that MG is parallel to their radical axis.
I was just thinking of it.
Oh, really? Yeah.
Can you draw it of the radical axis? Maybe this is through a special point.
Yeah. Yeah, it doesn't look like there's any special point, at least not that I can think of right now.
Yeah, I think we can delete it.
Okay. Yeah, it looks like a nice one. GM has to be perpendicular to NP. So I wonder if you reflect point M over point O, I think there's certain like special properties of that point. I'm gonna try it.
Maybe we can use inverse.
Inversion.
Yeah, inversion. Inversion will center all X, M, and G to. It takes M to a special point probably, but I don't know about G.
So let me try something here. Isn't there some property of M prime, like maybe not. Maybe I'm thinking of the cyclic quadrilaterals instead.
Can you reflect M across N and P?
Yeah.
And draw the circles with center and passes through M.
Okay. So those two circles?
Actually, GM is radical axis, maybe. It
Yeah.
must be, but how to prove it?
Yeah, I mean, I guess it's the same as saying that GN squared minus NM squared is GP squared minus PM squared. Hmm. Um, So yeah, LIKE pass through M. Yeah, can we make see. NP is the Gauss line. Yes. Yeah, NP is the Gauss line. So if we could extend AB and CD, AD and BC. Isn't there another property of the Gauss line, like that it's perpendicular to a bunch of other circles? Perpendicular to the Steiner line. What's the Steiner line? Do I need to extend the sides to draw the Steiner line? Yeah, okay, you have to complete it. Do you think it's worth drawing that? Okay. So G is the orthocenter of an isosceles triangle. Is there any way we can use that? So basically GE times OE is oh, sorry, it's not isosceles. Is there any transformation we can do to M and G? I'm going to delete these two circles for now, if that's okay. Just because I feel like showing that it's on the radical axis is the same as showing that gn squared minus nm squared is gp squared minus pm squared. But yeah, let me know if you want me to draw them back.
Feet of perpendiculars from B and C.
B and C to
BC and GB.
To BC?
No, GC and GB.
Oh, GC and GB. Okay.
They're on line LMI.
Oh, interesting. So these are actually the 2 feet of the perpendiculars.
Yep.
I didn't know that. So, oh, but I don't, no, that shouldn't, like CO.
This is iron lemma. We
Yeah,
can
iron
pull it
lemma.
from iron lemma.
Okay. Wait, are CO and R collinear? I'm sorry, are CO and Q and BO and R collinear? Let's see. I don't think so. Or I would be, looks almost like they are. That seems very surprising to me. Is that obvious?
Which is what is obvious?
That BO and R are collinear. So, or that BO is perpendicular to
Iron lemma. If you intersect AB with BC, you can prove it from iron lemma.
okay. I wonder if GM and GO are isogonal. Oops, sorry. I don't think they are actually. Well, actually, no, I'm not sure. No. Yeah, this is tricky. See, I'd like to reflect M over O and G over O, and then show that that new segment is perpendicular. I'm not sure if that helps. Yeah, let me try that one more time. Reflect M about O. Is there any special property of M prime? All right. Wow, this one's tricky. Wait a second. I still want to try reflecting O over the four sides, because if we do that, like what if we dilate this circle by a factor of 2? Actually, never mind.
Maybe we can go on.
Try the next problem. All right.
Yeah.
All right, so this problem was from a mock contest, the LMAO. I don't even know what that, I know the slang abbreviation, laughing my blank, but I don't know what they say that abbreviation was for. So we have the inner circle of ABC, and we draw the points of tangency. Circle A, B. Sorry, just a second. And then I'll just call the incenter I, even though it's not in the problem. So D, E, and F are the tangency points. U, V, and M are such that BU equals BM. So if I call this U, let's see, V is on AC. M is on BC. So this is M.
Well, is the midpoint of BC.
Or do you want me to, later on? So because BM equals CM, my bad. Right. So M is the midpoint of BC.
There are nice problems from this configuration.
Oh yeah, interesting.
Yeah, one of it is the Humpty and the Dumpty point.
The Humpty and the Dumpty point.
Yeah, the line passes through Humpty and Dumpty point is parallel to IO.
Oh, interesting. I didn't know that.
Triangle UVM. UVM.
Okay, so this is M. And this is U. And then I just need to draw the other circle. So that's point V. So yeah, is UV perpendicular to IO? Is that what you just said? So UV intersects EF at X. And EU intersects FV at S.
X is the midpoint of UV.
X is the midpoint of UV.
Yep.
Okay. So I see Manuel had hop off. All right. HT so this is S. XI meets the circle at P.
E is the same as mixed linear tangency point.
Interesting.
Because IX passes through the midpoint of BAC, arc BAC.
Is that obvious that G is the midpoint?
No, it's not.
Okay.
But we can prove it from spiral similarity.
Spiral similarity. Okay. And then we draw the circle MIX. Wow, this is a long problem. And it intersects UV again at Q. And let PD and IQ, PD intersect IQ and AS. Wow, this problem's very long. Sometimes long problems are really not that hard and they're just made to look complicated, but yeah, we'll see. So PD, we want it to intersect UV and AS. Is UV parallel to AS? It almost looks like it. So it intersects IQ. Oh, whoops. I want this point right here. So this should be pi. And this should be Z. sorry. We want to show YZUV is cyclic.
I think this cannot be easy because this one was problem 3.
Oh yeah? Yeah, then it must be pretty hard. So it looks like IQ is parallel to BC. Not sure if that looks true though. Yeah, IQ looks parallel to BC.
AGVIU is cyclic.
GVIU.
AGVIU.
Okay. And Y. Oh, and Y and Z. It looks like Y and Z are also on that. Oh, that's what we want to prove.
We first prove that UAGV is cyclic.
UAGV. Okay, so.
And it is true from spiral similarity.
Okay.
Then we see that IM equals to IV and IM equals to IU. So because AI is angle bisector, we have that AUIV is cyclic.
Okay, so IU is equal to IV from that. And then IV is equal to IM. Because CM is equal to CV. Yeah, okay. So I is the circumcenter of UVM.
Yep. Also, we have from Simpson line, IX is perpendicular to UV. Actually, it is also true from spiral similarity. Yeah.
Okay. So we know that do we know that AG, U, I, and V are cyclic? I guess I'm just trying to remember what we proved and what we still have to prove.
We first proved that AGVU cyclic from spiral similarity.
And then once we know AGVU is cyclic,
then we used UI equals to IV.
yeah, so then since UI is equal to IV,
And
then AGUIV is cyclic, right? And then we have to show Y lies on that, right? Yeah. So what is
We
Y?
draw VQ.
VQ.
Yep.
Oh, that's right. Yeah, we need to draw.
It was the definition.
Yeah. Y, what is Y again? PD intersects IQ at Y. I think you mean IG. Oh, IQ is. Oh, IQ.
That's true.
Yeah, because these are perpendicular. So yeah, that's true. It almost looks like FV is parallel to BC, but that's not true, I don't think. No. Okay.
Michael, do YV parallel to PQ?
YB and PQ. Let's see.
YV. No, YV.
Sorry.
Yeah. Yeah, YV.
The PQ. I think they might be parallel.
Could you check it?
Yeah. Oh, actually, you know what? I think it might just.
Symmetric, actually.
Yeah, it's not true. That you can see them getting closer. Yeah. If I make yeah, like there we go.
Yeah.
I guess G, Y, M are collinear.
G, Y, and M.
Yeah.
Do AYX is collinear?
I don't think so. Let's see.
Yeah.
Yeah.
Hide VM for now. After proving we can draw it.
Hide what?
VM.
This?
Yeah.
Okay.
Maybe we can redefine the point. We take the point from I parallel to BC and intersect it with the PD and the circle. No, with line UV.
So we take this parallel line and we intersect it with UE.
Yeah, so our aim is to prove that X, I, M, Q is cyclic.
IMQ.
I, M, Q, X.
Okay.
So we take the Q as the line from I parallel to BC and UV intersect.
Okay. So I can kind of define this as Q prime. Sort of. So, yeah. Okay. So we want to show IMQ is 90. So, yeah. That's interesting.
We can easily prove that GYM are collinear from ratios.
B, or what are the 3 points?
GYM.
Okay. So yeah, if that's true, then that means y would also lie on that circle, right? Because then GYI is 90 degrees, but GAI is also 90 degrees.
Yeah.
So yeah, so we know why UAGZ is cyclic, or what, and V. No, not Z. We know Y, U, V, A, and G lie on a circle. And I. Y, U, V, A, G, I. We just have to show Z lies on it. Do you see how to get those are collinear, or what the ratios are?
I will tell. My brain stopped.
Okay, sorry.
Can you name the intersection of I with BC?
GI with BC.
EI with BC. EI.
EI. Okay.
It's P.
PI. Sorry. Whoops. Let me try it one more time. It doesn't like it. Okay. Let me do this. And I'm going to unhide it in just a second. There we go.
Now we have dP over di equals to HP over HI, and it equals to IP over IG.
So BP over BI. Say that one more time.
The dP over di equals to HP over HI.
Okay.
And it equals to IP over IG.
Okay. So you said DP over DI is HP over HI. That doesn't sound right.
dP over di equals to HP over HI, and it equals to IP over IG.
But wouldn't that mean that DH would be the angle bisector of IDP? Oh, DP over DY. I was thinking DP over DI. My bad. No, that's perfectly fine. Yeah. Okay. So yeah, DP over DY is HP over HI, and then using harmonic stuff. That's IG over IP. IP over IG. Okay, so yeah, we can use that to prove that G, Y, and M are collinear. And then, so basically, if we draw this circle, we've proven that everything lies on it except Z, I think, right? Everything else we know lies on that circle.
First, we have to prove that Ix Q prime MR M is cyclic.
Oh yeah, Ix Q prime M. Yeah. Okay. Is there another point on that circle? Possibly. Let's see. Not that I see.
Oh, I saw the proof.
Okay.
We have IV squared equals to Ix times Ig, but we know that IV equals to Im.
Okay, so
And
IM.
Ix times Ig equals to Iy times Iq prime.
So that proves, so IM squared, so angle IM Q prime is 90, and so that proves that that's cyclic. Nice proof. All right. So that means that we can call this Q now. I'm going to leave it as Q prime just because if I write up the proof, I would start out calling it Q prime. But yeah, I like that. So IM squared is IV squared, which is Ix times Ig. Wait, so
Ix times Ig equals to Iy times Iq prime.
yeah. Is it obvious though that IV squared is Ix times Ig? Yeah, because we knew that was
Yeah.
cyclic because we proved, yeah. Okay. So I could try just writing up what we have so far.
It will be nice.
Yeah. So let the parallel through I to BC meet UV at Q prime. Okay. So you said, so by spiral similarities, we can show AGUV is cyclic.
Because we have U equals to CV.
Yeah,
CV
okay.
equals to GC.
So BU equals CV. So I've seen this in a bunch of videos, but that means that AG UV is cyclic. So, but by a spiral similarity. And then, okay, so first we want to show that I lies on that circle, but that's true because I is on the perpendicular so we have IM is equal to IV, which so IM equals IV and IM equals IU. So an AI bisects angle BAC, and so that implies that AGUIV is cyclic. Oops. And but yeah, how did you know that G was the midpoint of arc BAC?
First defined G as midpoint of arc BAC,
Mm-hmm.
and we proved from spiral similarity.
Oh.
Because we have GUB and GVC are congruent.
So first you define G as the midpoint of arc BAC, then how do you know G, X, and I are collinear?
Because IAG is 90 degrees.
But that proves that G, X, and I are collinear? Like, how do you know X lies on IG?
What is the definition of X? Midpoint of UV?
X is where UV intersects EF. Did we prove that? So did we prove that X is the midpoint of UV?
If you define it as the intersection of IG and UV, then we see that IX times IG equals to IF squared.
Okay. And does that prove that X lies on EF?
I'm confused, wait.
Yeah.
If you define it as the intersection of IG and UV, then
we
know
need to prove that UF is equal to EV. So by many layers, so many layers of F, X, and E, we have FU over FA times EA over EV times XV over XU, but AE is equal to AV.
I like that.
So we need FU is equal to EV, and I think that I think that we use the just the distance. Because BU is BM, and BF is AC is BA plus BC minus AC and give over 2.
So FU is AF or is BU minus BF?
Yeah, and but yeah, and BU is BM is a half of BC. BC over 2 minus BA plus BC minus AC over 2. BA plus BC minus AC over 2. Yeah. Yeah, and that will be AC minus AB over 2.
Okay.
Because yeah, and that will be AC, yeah, over 2. Yeah, the same with EV.
Sorry. See if that does anything. And then by Menelaus, FU over FA times AE over EV. AE over EV. Okay. Let's check the chat. And so once we know Vx equals XU, then that means GX and I are collinear. Is that yeah, because we know AGUV is cyclic. So so GX, so this right here proves that GX and I are collinear. And then, so one thing we wanted to show is, so you used ratios to show IY. So how is Y defined? PD and IQ prime. So we wanted to show Q prime equals Q. Yeah, how did we define Y?
We defined Y as a line from I parallel to BC intersect PD.
Intersect PD, okay. So meet, also I'll say meet UV and PV at Q prime and Y prime. And so IY, so we want, so I'm going to write the ratio. So dP over dy prime.
We could prove IXG are collinear also from Simpson line actually.
Oh, really? Hold on 1 second. You could also use the Simpson line argument.
Yeah.
All right. I'm just going to finish writing this out. So HP prime over HI, which is IP over IG.
Actually, not P prime, Y prime.
Y prime, yeah.
And I guess it's easier to prove from PD over PY prime, not DP over DY prime.
Sorry, so you said that
PD over PY prime equals to PH over PI and ET equals to PI over PG.
okay, so PD over PY prime.
Yeah.
PY prime, it's PH over PI.
And it is PI over PG.
Which is what? Say it one more time.
PI over PG. It's P.
PI over E?
PI over PG.
Oh, PI over PG, sorry. And this implies that
Y prime is on GM.
Y prime is on GM. All right. So PD is supposed to intersect IQ and AS. So, okay, eventually we'll show that Q prime equals Q. So, okay, so then we have IM squared equals IV squared. I'm just going to write this out really quickly because I know we're almost out of time. But basically,
You send the files today?
yeah, IM squared is IV squared, which is IX times IG. Oh, it's right here. Which is IY prime times IQ prime. Sorry. GeoGebra is just slow. I don't know why it keeps, got to drag this down lower. So this is IY prime times IQ prime. So that implies that angle IMQ prime equals 90. That implies that IMQ prime X is cyclic. And that implies that Q prime equals Q. Okay. So I think that's as far as we got.
No. I think I can solve this problem. Just quickly.
Okay.
So can you draw the circle AUV?
ADV?
AUV.
AUV, yeah.
Yeah. So we need to prove that Z is lie on that circle too, right?
Mhm.
So we claim that AX, AS, AU, and AV is harmonic, right?
AX, AS, AU, and AV are harmonic, is a harmonic bundle.
Yeah,
Yeah.
but
Okay.
X is the midpoint of UV, so AS will be parallel to UV, right?
Yes.
Yes, so let's call AS, cut the circle AGUV at the point Z. We will prove that Z, Y, and P is collinear, right?
Okay.
Okay, so because AZ is parallel to UV, that means AZ is perpendicular to IG, right?
AZ is perpendicular to IG, yeah.
So A will be Z will be the reflection of A through IG.
Okay.
So arc AG will be equal to arc ZG, right?
So wait, how do we know AZ is perpendicular to IG?
Because AZ is parallel to UV, we define Z as AS, cut the
Okay.
circle. Yeah. So we need to prove that we need to prove Z, Y, and P is collinear, right?
Mm-hmm. Yes.
Which means we need to prove angle GYZ plus angle GYP is 180.
Mm-hmm.
But angle GYZ is equal to angle AIG.
Okay. Yeah, because arc GZ is equal to arc AG.
Yeah, and if you call let AI cut the circle ABC at one point.
Okay.
Yes. Yeah. Could you can draw MJ?
Okay.
Can you
Hold on one
MJ?
second.
Yeah. Okay. So we need to prove that angle AIG plus angle GYP is 180, right?
Mm-hmm.
Yeah, but angle AYG is AIG is plus angle GIJ is 180. So we need angle GIJ is equal to angle GYP, right?
Mm-hmm. Yeah.
Yeah, but we have that GM times GJ, JM times JG is equal to JI square.
Yeah, actually because PJIY is cyclic, so PIJ is PYJ, and from there it would follow that those two angles are equal, right?
Yeah. So P, Y, and Z will be collinear, and that will solve the problem.
Okay.
How do we know Pi Y prime J is cyclic?
PI Y prime J is cyclic. Because angle JPI is 90 degrees, because GJ is the diameter, and angle I Y prime J is 90.
Yeah.
Okay.
All right. I'm not going to type. So that all made sense to me. I like that. I'm not going to type it up just because it's the end of the session. but that was a really nice solution. I like how we combined everyone's ideas. It was really cool. So thanks for that. All right, so for everyone watching on YouTube, thanks for watching, and thanks everyone for participating on the session. If you'd like to join future sessions, feel free to email me at mgreenb801@gmail.com. So the sessions are at 8 a.m. US Central Time every Sunday. Have a good one.